talk about quadratic functions and their graphs. So this will be part 1, quadratic functions and their graphs, part 1. This is intercept form. It's very easy to find the x-intercepts from this form of the function. So let's think about how do we find x and y-intercepts. To find the x-intercept of, let's start with the y-intercept. To find the y-intercept of a graph, we let x equal 0. So I put 0 in for x. I get 0 minus 4 times 0 plus 2. Negative 4 times positive 2 is negative 8. So my y-intercept is 0, negative 8. To find the x-intercepts of a function, I let y equal 0. And recall that y and f of x are synonymous, so that's the same thing as saying 0 is equal to x minus 4 times x plus 2. So I want you to think about this as you look at it. In order to make this equal to 0, what has to be true about this situation here? Notice I have two numbers multiplied together, a number that I would get when I put x in here, so this number x minus 4 times this number x plus 2. One of those two numbers has to be 0 in order for the product of the two numbers to be 0. So what would make x minus 4 equal to 0? Well, x would have to be 4. What would make x plus 2 equal 0? Well, x would have to be negative 2. So that's why the opposite of the number in the parenthesis is used for the x-intercept, because if I put 4 into the graph, I would get 0 for y. If I put, into the equation, if I put negative 2 into the equation, I would get 0 for y. So those are my x-intercepts. So this gives me 3 points on the graph already. So I'm going to go ahead and plot those 3 points. I have the point 4, 0, negative 2, 0, and 1, 2, 3, 4, 5, 6, 7, 8, 0, negative 8. Now if you look at this, you might think, I want to know what's happening to the graph. It's going to go down. It looks like it's probably going to dip down a little farther and then come back up, because this point is not halfway in between these two. I need to find the point that's halfway in between. And it would have been better if I'd drawn this a little straighter. I'm going to do this because I think visually it's going to help you out if you see it looking a little straighter. So let me try this again. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that looks a little better. We can see visually here that it's going to that the lowest point of the graph is going to be somewhere to the right of the y-axis, because we know that with symmetry, the middle point of this function has to be somewhere halfway between these two values. This is 4, this is negative 2. Halfway between those two numbers, and you could do that by averaging them, is 1. So we know that this line is going to divide the graph in half. So I know the vertex, the x-coordinate has to be halfway between the two zeros. Halfway between the two, the zeros are another name for x-intercepts, between the two x-intercepts. And I'm going to put zeros in parentheses because that is another name for the x-intercepts. So I know that the vertex has to be positive 1 something. So how do I figure out what the y is? Well, I'm going to let x equal 1 in the equation. So f of 1 is equal to 1 minus 4 times 1 plus 2. And that is equal to negative 3 times 3, which is negative 9. So my vertex is at 1, negative 9. Notice that fits the pattern that we looked at when we looked at the over 1, up 1 pattern. So notice this has a slope of 1. If we were to multiply this out, it would just be 1x squared. So we go over 1, up 1, over 1, up 1. If we go over 2, we'd go up 4. If we go over 3, we'd go up 9, which would get us up to the x-intercept here. So how do you, just to summarize, if I have a quadratic function in intercept form, I'm going to find the x and y intercepts by substituting in 0 for x and 0 for y. I'm going to plot those and look at the graph, because that really helps when you actually plot the things you know and look at the graph. Halfway in between the two x-intercepts is going to be the line that contains the vertex. So I will know the x-coordinate of the vertex. I could find that by averaging those two numbers if I wanted to. 4 plus negative 2 divided by 2 is 2 over 2, which is 1. So that's another way to get that value besides just looking. Once I know the x-coordinate of the vertex, I'm going to plug that into the equation to find the y-coordinate of the vertex. So that's how you graph using intercept form.